Now there will be a discussion on second PU or class 12 physics chapter electromagnetic radiations. Let us understand the concept of electromagnetic radiations. To understand the concept of electromagnetic radiation, let us have a discussion on the matter and energy and the interaction between them. The interaction between the matter and energy. As you know, the entire space, the universe, of course, is the infinite magnitude of space, which contains very small amount of, comparatively small amount of matter in the form of stars and planet. Sun is one of the stars. As you know, Sun is one of the stars. And the vast space, empty space, contains many electromagnetic radiations. To understand the concept, the meaning of electromagnetic radiations, let me go in details about the matter at the microscopic level. What is matter made up of? Matter is made up of the smallest particles, smallest possible particles called as atoms. Some atoms make molecules as well. What is an atom? Very small size of nanometer size. What is nanometer? The size, just imagine the size of the atom. If you take very small particle, maybe in the form of solid or liquid, it contains billions of atoms, or say trillions of atoms, countless number of atoms. Imagine the size of atom. That is the size of atom. Matter is made up of atoms. What is atom? Atom is spherical in shape. That is, inside what is that? A small sphere is there, in which protons and neutrons are occupying with a compact, what is that? With a compact binding between them into a small volume, very small volume compared to the volume occupied with electron cloud, electron covering around the nucleus. The volume occupied with electron is comparatively larger than the volume of the nucleus. This is called nucleus sphere. And we have discovered about 120 atoms. So all matter is made up of atoms. How many atoms we have discovered? 120 atoms. On what basis the atoms are classified? On the basis of electrons and protons. As you know, electrons carry negative charge, protons carry positive charge, upon neutrons doesn't carry any charge. On the basis of number of electrons and protons present in the atoms, we are classifying. One electron system contains one electron and one proton called hydrogen atom, of course. Two electron system, two electrons, two protons and some neutrons. 10 electron system, 10 electrons, 10 protons. And 120 electron system, 120 electrons, 120 protons and some neutrons in the nucleus. Bigger atom, that is bigger and bigger in size. On the basis of these electrons and protons, we have classified, that is, we have discovered about 120 atoms, And let us look at the structure of the atom. Nucleus carries positive charge and electrons carry negative charge. Just because of the existence of these fundamental particles, charged particles, now the phenomena has come into picture: electric field, magnetic field, electricity and magnetism. Just because of the these fundamental particles, the charged particles. Before going to the electric and magnetic field, let us talk about the structure of this atom. The structure of the atom, what is that? Here I am taking about that, the entire structure of this atom. Electron cloud and nucleus. Electron clouds entirely called negative charge, nucleus positive charge. Now the phenomena of electricity or electric field is because of the movement of the charge, or the what is that? The existence of the positive charge and electron separately, that is a material or like this. If there is a positive charge, maybe of protons, one or more protons, if there is an electric charge, maybe of one electron, many electrons, this that is positive charge at rest, I am talking about negative charge at rest. There is always electric field around it. Electric field around it, electric force, electrostatic force around it, electrostatic force around it. This electrostatic force is uniform, this electrostatic force is uniform. Electric field is uniform, electric force is uniform. That is direction of the electric field, direction of the electric field. Away from the center of positive charge towards the center of the negative charge. It is the one direction, it is based on the other positive charge. When you bring into this, within this purview, it is getting repelled away from this direction, repelling away, direction of the electric field. If the same positive charge is bring in the purview, that is within this atmospheric electric field, it is getting attracted towards this direction of electrostatic force. That is the direction of the electric field towards the negative charge, direction away from this charge. Electric field is uniform as long as the charges are at rest. If the charges are started moving, any kind of movement, this movement or this movement, exert variation of electric field. Electric field variation arises. That is called electric current, the power. So this electric field variation, one important. Any variation of electric field, that is movement of charge, causes variation of magnetic field in the atom or the material. This is electric field, it is because of negative or positive charge or proton or electrons when they are set into motion. What is magnetic field? Magnetic field is because of the electron, it is rotating about its own axis. That is, electron in addition to revolving around the atom, it is rotating, every electron is rotating, spinning around its axis. That is electron spin. That is, the electron spin or rotation about its axis produces some field called magnetic field or magnetic force. Direction of the magnetic field, when the electron spins in the clockwise direction. And the direction in the opposite direction, if the electron spins in the anti-clockwise direction. There are only two possible spins, clockwise and anti-clockwise. And interestingly, this produces magnetic field. This electron spin produces magnetic field. And interestingly, most of the atoms contains electrons are pairing up. That means, when you look at the structure, electronic structure of the atom, electrons arrangement in the shells, main energy levels. Cell, there is a lower shell, upper shell. And again, main shell or main energy level into subshells. Each one has subshells, and each subshell have orbitals, different orbitals. And every orbital containing two electrons only. One electron spins in clockwise, other electron spins in the opposite direction. Thereby, electric field getting cancelled by their itself. Electron pair. So, in most of the atoms, electrons are paired up, and there is no magnetic field getting cancelled by itself. But there are atoms containing some unpaired electrons. these unpaired electrons, one or two electrons, today's unpaired electrons always rotate in the clockwise direction. And this clockwise direction, if all the electrons, unpaired electrons are oriented only in one direction, then produces a net magnetic field. But unfortunately, in atoms like this, that orientation of the electrons spin in the clockwise, but their orientations are different. They are in different directions. The net effect is again nullified by itself. But it is possible to have, that is, magnetic field by processing of the material. What is processing? By having some crystalline structure, proper crystalline structure, processing of material. By using what is that is heat treatment or electric treatment, it is possible to have all the unpaired electrons to have one orientation. Clockwise direction is spinning one direction with one orientation. All the orientation, what is that? Each electron has this magnetic field, and each magnetic field is sum up. That is sum up into a big magnetic field in the same direction, produces magnetic field or magnetic force. The magnetic field by the material. So that is by processing. It is called permanent magnet. We can make magnetic material using such materials. So most of the magnets we are making use of mainly three metals, that is iron, cobalt, nickel, because these metals contains more number of unpaired electrons in the d shell orbitals, that is in subshell somewhere around that, containing 4 unpaired electrons, 5 unpaired electrons, or 6 unpaired electrons. So it is possible to have, that is, processing into make all the unpaired electrons of all the atoms, that is numerous, countless number of atoms, countless number of electrons, to have only one orientation that produces a magnetic field of only one direction, magnetic field, strength, magnetic force arises in the material. That is called a magnet, permanent magnet. In the permanent magnet, how does magnetic force look like? It is electric force, electric field. Magnetic field is like this always. Nice. Magnetic force or magnetic field always arises from one point to other point, direction. That is called magnetic lines of force. It is called as north pole, it is called as south pole. It is around the space around the material, magnetic material. But inside the material, the magnetic lines of force from south to north pole and south pole. Always magnet has dipole, north pole and south pole. When you break now, again what is that? North pole and south pole, there are two magnets with north and south poles, always in dipole. Magnet with monopole will never arise. That is, magnetic force is because of these electron spins. Some of the electron spins in one direction make a magnetic force, magnetic permanent magnet. So this is by processing as well as by applying electric current, it becomes sometimes magnet. That is material metal. That is electric field and magnetic field. Now, very interesting point is here. To understand the basic concept of electromagnetic radiations, we have to understand this electric field and magnetic field. One important point we need to stress upon, where there is a change in the electric field, it is changes because of movement. Electric field changes when there is a movement, either this or this. Electric field changes. Where there is a change in electric field, there is always a change in magnetic field, even though material is not magnet. Magnetic field arises and changes. So that is always associated. Any variation of electric field changes the magnetic field, or any variation of magnetic field changes the electric field. Both are associated, coupling with each other. That is, come true by reality, by what is that, by the device, what your real in device we make, that is a conversion of what is that mechanical energy into electric energy. In the what is that in nature we have different forms of energy. It is possible to convert one into other, but we cannot destroy. That is called as law of conservation of energy. So in this case, what is that? In this, talking about this, we are converting electric energy into mechanical energy into electric energy. Practically, we have done it. We are using it today. So we are doing, so what is that? Is a generation, electric power generation. Mechanical energy into electric energy. That is by what is that wind, or what is that flow of water, hydroelectric, converting mechanical energy into electric energy using magnetic energy. That is one way. And other reverse possible, converting electric energy what is generated into mechanical energy for electric motor purpose. Electric motors for making what is that mechanical movement. There are two ways. In both the ways, what is that? That is Maxwell's. It has come from the Maxwell's equations. Now it has become what is that? A rule. What is that? The Fleming's right hand rule, Fleming's left hand rule. What is that actually a rule? It is the conversion of mechanical energy into electric energy, right hand rule. Conversion of electric energy into mechanical energy, left hand rule. So the energies I am talking about, that is mechanical energy, electric energy, magnetic energy. The energies are scalar, no direction. But if you see in the form of force, is that the direction. That is why when you talk about these energies in terms of forces, that is a mechanical force in this direction, magnetic force, magnetic field or force, electric field in this direction, perpendicular to each other. If there is a change, what is that? That is motion or mechanical movement, mechanical force in this direction changes, there is a change in magnetic field, changes in magnetic field. This magnetic field change into electric energy. So where the change in the magnetic field changes the electric field. This force generates electric force in presence of magnetic force. These are perpendicular to each other. That is one way. The other way, when you pass electric current, this is the direction of the electric field, direction of magnetic field. When you change the electric field, there is a change in magnetic field in the form of what is that mechanical field arises, mechanical force. Electric energy into mechanical energy, mechanical energy into electric energy. But in the form of force, what is that? Actually, you are doing it. A change in the magnetic field because of mechanical action changes the electric field. Same concept. When there is a change in electric field, there is a change in magnetic field appear in the form of magnetic force, mechanical force. The same concept. Practically, it has come to prove that where there is a change in the magnetic field, there is a change in electric field. Where there is a change in electric field, there is a change in magnetic field. That is Fleming's right hand rule, Fleming's left hand rule. That has come from Maxwell's equation. Electric field and magnetic field always associated with each other. Where the field changes, electric field changes, magnetic field also changes. So this concept is very important to understand. So now we need to stress upon what is that? Using this electric field and magnetic field, let us understand what is the meaning of these radiations. Now let us talk about the energy conversion. We know that just told you we can convert electric energy into other electric energy, that is electromagnetic radiation. There is another form of energy. And convert heat radiation into electromagnetic radiations. Look at this concept, very important, need to understand How these electromagnetic radiations are produced. Talk about the atom microscopic level. What is an atom? Atom is made up of a positive charge, negative charge. All electrons together is negative charge. All protons together positive charge. Center of positive charge, center of negative charge coincided exactly when there is no external force on the atom. Any external pressure, any kind of external pressure on the atom. Exactly coincided. There is no electric field. Electric field is zero. But by the electric current, by electric volt or electric pulse on the material like this, containing so many, billions of atoms. I am talking about the atom by atom. If we talk about the atom here, that is centers are coincided. By the application of electric pulse on the material, there we see a distortion of the charge centers, like this. Distortion in one direction, that is negative and center, are getting distorted by the application of electric pulse on the material. That is called as oscillation or dipole oscillation. The atom with distortion between the electric center, positive center, negative center. This distortion arises, will give field, electric field strength. Here, as they move away from here, electric field increases oscillation. With this oscillation, when they move away from here, distortion, electric field increases, reaches the maximum. When the distortion is maximum. But this distortion will not stay back, will again oscillate back. The result come back. Oscillate back. When they are approaching each other, back to this, the electric field decreases when they combine, coincide, becomes zero. Again it will not stop. Now oscillation in a different direction. That is positive and negative direction, change the direction. So positive to this side, negative to this side. The distortion in this direction. So with this distortion, electric field, but in the opposite direction. Electric field in one direction, electric field in the opposite direction. Increases, negative field. Increases, and let's say decreases to minimum. That is, other direction increase. When they move away from this, maximum negative electric field. Then again go back oscillation. Go back to this position. So while doing so, it is decreases, becomes zero. That is one oscillation. First, then this, then back to this. Again to this and back to this. It's called one oscillation. One oscillation or one wave. It is oscillation of electric field. When the electric field is oscillate like this, it is what amplitude. So this electric field oscillation or variation is always associated with magnetic field. So when this electric field is vary, magnetic field also begins to vary in the material, in the atom. How does it vary? It is in the perpendicular direction to this. If this oscillation in this direction, that is in the plane of the blackboard, oscillation in the plane, that oscillation of magnetic field in the plane perpendicular to the blackboard, magnetic field. So that is electric field, this is magnetic field. Electric field in the plane, that is Y plane, that is the plane of the blackboard, oscillation. And magnetic field is in the Z direction, in the plane perpendicular to the blackboard. This is lying on the plane, this oscillation is lying in this plane. So magnetic field and electric field and magnetic field, they are perpendicular to each other. When there is electric field, there is magnetic field, but they are in the same phase. That is called a wave oscillation. This is a wave like Oscillation is oscillation of electric field and magnetic field. It's like this one wave. This electric oscillation inside the atom or inside the material, that is energy, electric energy. Sometimes this wave is detached or separated from the atom or the material. Once it is separated, what happens? Will this electric field and magnetic field stay over and go back? Never. This combination, what is that? This couple, what is that? Electric field, magnetic field, they are in the perpendicular direction, will migrate, will travel, will propagate in the space at very high speed, that is 3 × 10⁸ meter per second, velocity of light. That is travel at very high speed. Once it is come out into space, that is the energy. What is energy? Electromagnetic energy generated from the material by change of electric current into radiation. That is radiation emitted. So these radiations, what is can travel any long distance. Entire what is that universe space, it can travel with the speed of this light until it is obstructed by the material like these atoms and molecules. It is called electromagnetic radiations. What is electromagnetic radiation? Electromagnetic radiation is variation of electric field with variation of magnetic field, wave nature, and that is what is that carrying energy, that is energy conversion of one form into other form. They travel in a distance, what is that, in the space, in the form of energy carrier. It is an energy carrying from energy from one space to other space. It is called electromagnetic radiation. It is by the effect of electric current generated. Not only by the effect of electric current, it is also generated by the effect of heat, thermal energy. By applying electric energy, it is generated. It is possible to have applying IR radiations, that is thermal energy, heat radiation to the material. The material is heated. So in some material it happens like this, oscillation, with atomic oscillations or molecular oscillations. In some cases molecules have what is that? Atoms vibrate. Between the atoms vibrate about the bond. That is also possible, oscillation of what is that? But in atoms, what is that? Only this cloud, the charges oscillate like this. This oscillation, that is heat radiations, converted into what is that? Electromagnetic radiations, that is electric dipole oscillation. It is come out as radiations and travel in space. They are also called as electromagnetic. This is a kind of what is that conversion of one energy into other energy. The other energy formation is electromagnetic radiation in this case. So now this is called as electromagnetic radiation, and this electromagnetic radiation, what is that wave? It is always propagating like this in space. Propagation of this electric field or magnetic field in the direction perpendicular to the oscillation of electric field and oscillation of magnetic field. These two are perpendicular, and the direction of propagation is perpendicular to this electric field and magnetic field. That is what is a three-dimensional space. That is called electromagnetic radiation traveling at the speed of light. Now this electromagnetic radiation is characterized by, it is now characterized by using these properties, that is wavelength, frequency, wave number, the energy. So these properties explain, or what is that, will characterize the electromagnetic radiations. Upon this characterization, we have different types of radiations. On the basis of the physical properties, of these waves, that is gamma ray, X-ray, UV ray, visible ray, IR ray, microwave. Radiation of highest energy, radiation of lowest energy. So let us talk about this classification of, that is EM, electromagnetic radiations. on the basis of these properties in the next session. That is why we need to stress upon what is that E is equal to mc square. So here I am talking about what is the conversion of electric energy into these radiations, conversion of heat radiations into the conversion of heat into this radiation, that is by physical process or chemical process of a material. But there is also, that is not only law of conservation, there is also conversion of mass into energy is also involving Einstein's equation. When the mass is converted into energy, mass disappears in the form of energy. Quite a large amount of energy is liberated, because any mass disappear, any mass conversion is multiplied by c square, a big value. Okay. So enormous amount of energy in the form of heat liberated when the mass disappears. Mass into energy conversion, Einstein's equation. So we shall continue in detail more about this in the next section.